In 2014, a team of psychologists published a paper in the journal Science that caused significant controversy in both academic and popular circles. The researchers had studied cognitive differences between people from different regions of China, not different countries, not different ethnic groups, but different agricultural zones within the same country, with the same language, the same government, and largely the same culture. They found something striking. People from regions of China that historically grew rice thought differently from people from regions that historically grew wheat. More specifically, rice farmers and their descendants showed significantly higher levels of holistic, interdependent thinking, the tendency to see relationships between objects rather than focusing on individual objects, to prioritize group harmony over individual goals, to think about the world as a network of connections rather than a collection of separate things. Wheat farmers and their descendants showed higher levels of analytic, independent thinking, the tendency to focus on individual objects, to categorize things into distinct groups, to prioritize personal goals and individual rights. The researchers called this the rice theory, and they proposed that the difference in thinking style was not caused by culture, religion, or history, but by agriculture, by the specific demands of growing rice versus wheat over generations, by the crop itself. Rice is one of the most labor-intensive crops in agricultural history. It requires flooded paddies that must be built, maintained, and drained in precise coordination. It requires shared water systems that must be managed collectively. One farmer cannot control the water supply independently without affecting everyone else. It requires synchronized planting and harvesting that work best when entire communities act together. Growing rice well requires cooperation on a scale that growing wheat does not. Over thousands of years, this agricultural requirement shaped the people who practiced it, not genetically, culturally, institutionally, cognitively. The crop created the culture created the people created civilization. What if rice had never existed? What if the grain that feeds more humans than any other had remained a wild grass in the wetlands of southern China? Half the world as we know it would not exist. The most important grain you don't think about. More humans eat rice as their primary staple than any other food on Earth. Approximately half the global population, 3.5 billion people, depends on rice for the majority of their daily calories. In Asia, where the majority of the world's population lives, rice is not simply a food, it is the organizing principle of agriculture, of the calendar, of ceremony, of social structure, of language itself. The word for rice in many Asian languages is the same word as the word for food or for meal. In Japanese, the word gohan means both cooked rice and meal. In Vietnamese, the word com means both rice and food generally. The linguistic equivalence is not coincidence. For most of Asian history, to eat was to eat rice. Everything else was accompaniment. Rice was first domesticated approximately 9,000 years ago in the Yangtze River valley of what is now central China. The wild ancestor, Oryza rufipogon, a wetland grass, was transformed through millennia of selective breeding into the domesticated Oryza sativa, the rice plant that now feeds half the world. From China, rice cultivation spread south and west over thousands of years, to Southeast Asia, to India, to the Middle East, to Africa, eventually to the Americas through the slave trade. The demands of rice cultivation are extraordinary. A rice paddy is not a field. It is an engineered environment, a precisely leveled basin that can be flooded to a controlled depth and drained at specific times. Building a rice paddy on a hillside requires terracing, cutting level platforms into the slope, and building retaining walls to hold them in place. The rice terraces of Banaue in the Philippines, the Honghe honey rice terraces in Yunnan, China, the terraced paddies of Bali. These are not natural landscapes. They are among the largest and most complex engineering projects in human history, built without machinery over centuries and millennia, maintained by the communities that live within them. The water that flows through a traditional rice paddy system is managed communally. In Bali, a system of water temples, religious institutions that also serve as irrigation management organizations, has coordinated the water supply for rice paddies across the island for over 1,000 years. The priests who manage the temples are also water engineers. The religious calendar is also the agricultural calendar. The spiritual and the practical are fused in an institution that allows thousands of farmers to share a single water supply without conflict. When the World Bank arrived in Bali in the 1970s with plans to modernize Balinese agriculture, they recommended that farmers abandon the traditional temple-based water management system in favor of modern irrigation management and continuous planting to maximize yields. The farmers followed the advice. Pest populations exploded because the synchronized planting that the temple system enforced had previously allowed fields to go fallow simultaneously, breaking the pest cycle. Yields collapsed. After nearly a decade of failed modernization, researchers studied the traditional system in detail and discovered that the water temples had been performing sophisticated pest management and water optimization that no modern system had successfully replicated. The World Bank reversed its recommendations. This is what rice does. It creates institutions. It creates cooperation. It creates systems of collective intelligence that outlast the understanding of the people who built them. Rice, empires, and the control of Asia. Whoever controlled rice controlled Asia. This was not a metaphor. It was a military and political reality that structured the history of the continent for thousands of years. The great empires of Asia were rice empires. The Han dynasty of China, which unified the country and established the administrative structures that persist to the present day, built its power on the rice-growing regions of the Yangtze River Valley. The Khmer Empire that built Angkor Wat, the largest religious monument in the world, was sustained by one of the most sophisticated hydraulic rice cultivation systems ever constructed. The network of reservoirs, canals, and channels that surrounded Angkor managed water for rice paddies across an area of hundreds of square miles, sustaining a city of perhaps 1 million people, among the largest cities in the world in the 12th century. When the hydraulic system failed, through a combination of silting, climate stress, and military disruption, Angkor collapsed. The rice stopped. The city emptied. The jungle reclaimed it within generations. The fall of one of the greatest civilizations in Asian history can be traced through archaeology and climate science to the failure of its rice irrigation system. Japan's feudal political structure, the samurai class, the daimyo lords, the shogunate, was organized around rice. The wealth of a feudal domain was measured not in gold or land, but in koku, the amount of rice it produced annually. One koku was approximately the amount of rice needed to feed one person for 1 year. The salary of a samurai was paid in rice. The power of a lord was measured in the koku his domain produced. When Toyotomi Hideyoshi unified Japan in the late 16th century, one of his first acts was a nationwide cadastral survey, a measurement of every rice field in the country, to establish the koku value of every domain and every lord. The census was not of people, it was of rice. The political economy of medieval Japan was a rice economy, and the transition away from it, when the Meiji government abolished the samurai class and restructured the economy around cash rather than grain, was one of the most traumatic social disruptions in Japanese history. Samurai who had received their income in rice suddenly found themselves holding a commodity rather than a salary. Many were ruined. The social class that had defined Japanese society for 5 centuries was dissolved not by revolution, but by the demonetization of rice. In colonial Southeast Asia, the control of rice was the control of populations. The Dutch in Indonesia, the French in Indochina, the British in Burma, all recognized that controlling rice production and rice distribution was the mechanism through which you controlled people who would otherwise resist. Tax rice, force rice cultivation, export rice, and let the people who grew it go hungry if necessary. The great famines of colonial Asia, the Bengal famine of 1943, the Vietnamese famine of 1944 to 45, were not primarily caused by drought or crop failure. They were caused by the extraction of rice from populations that needed it to survive. Rice and the shape of Asian civilization. The rice theory that researchers proposed in 2014 was controversial partly because of its implications. If the crop you grow shapes how you think, if rice farming produces collectivist minds and wheat farming produces individualist minds, then some of the deepest cultural differences between East and West are not the product of philosophy or religion or political history. They are the product of agriculture, of the specific demands of specific grains grown in specific soils under specific rainfall patterns. The evidence the researchers marshaled was substantial. They surveyed more than 1,000 participants from rice-growing provinces and wheat-growing provinces within China, controlling for income, education, and modernization. They found consistent differences in cognitive style. Rice region participants were more likely to draw diagrams that showed relationships between objects. They were more likely to resolve conflicts through compromise. They were more likely to categorize objects by relationship rather than by category. They were more likely to express loyalty to groups over loyalty to abstract principles. These are precisely the cognitive characteristics that Western observers have historically attributed to Eastern culture or Confucian values. The emphasis on harmony, on collective obligation, on relationship over rule. The rice theory suggests these characteristics are not primarily philosophical. They are agricultural. The practical consequences of this insight go further than academic psychology. Many of the most significant misunderstandings between Western and East Asian governments, corporations, and individuals in the modern era have involved exactly these differences. The tension between individualist legal frameworks and collectivist social expectations, between the Western emphasis on explicit rules and the East Asian emphasis on relationship and context. Trade negotiations, corporate acquisitions, diplomatic agreements, all have been complicated by cognitive differences that both sides have assumed were cultural or historical, when they may be, at root, agricultural. Subsequent research has found similar patterns in other parts of the world. Regions of sub-Saharan Africa with histories of intensive collective agriculture show different cognitive profiles from regions with more individualistic farming traditions. The relationship between agricultural system and cognitive style appears to be real, robust, and cross-cultural. Rice did not just feed Asia, it thought Asia.
The Green Revolution and its costs.
In the 1960s, a plant geneticist named Norman Borlaug developed high-yield varieties of wheat that transformed global food production and earned him the Nobel Peace Prize. The rice component of this transformation centered on the International Rice Research Institute in the Philippines, which developed IR8, a semi-dwarf rice variety that produced 2 to 3 times the yield of traditional varieties under ideal conditions. IR8 spread rapidly across Asia in the late 1960s and 1970s. In the Philippines, rice yields doubled in a decade. In India and Pakistan, new varieties transformed countries that had been dependent on food aid into net grain exporters. Borlaug himself acknowledged the limitations of what he had achieved. In his Nobel acceptance speech, he described the Green Revolution as buying time, not solving the underlying problems of population growth and resource depletion, but creating a window in which those problems might be addressed. The window, he suggested, was perhaps 3 decades.
The costs of the Green Revolution in rice were significant and are still being reckoned with. The high-yield varieties required chemical fertilizers, pesticides, and irrigation at levels that traditional varieties did not. They replaced the extraordinary diversity of traditional rice varieties. Thousands of locally adapted cultivars developed over millennia, with a small number of high-yield monocultures. Scientists estimate that before the Green Revolution, Asian farmers grew approximately 100,000 distinct rice varieties. Today, a handful of varieties dominate global production. The genetic library that took 9,000 years to build was largely discarded in a generation. The International Rice Research Institute has spent decades collecting and preserving traditional rice varieties in a gene bank, a refrigerated vault in the Philippines that holds over 130,000 samples. It is the largest collection of rice genetic diversity on Earth, and it exists because the diversity was nearly destroyed. The farmers who created those varieties over millennia received nothing for them. The genetic knowledge encoded in their crops was taken, cataloged, and locked in a vault, without compensation, without acknowledgement, without the political recognition that might have been owed to the people who spent 9,000 years making rice what it is. The social costs of the Green Revolution were equally significant. Traditional rice cultivation had been organized around collective labor systems, cooperative arrangements for planting, irrigation management, and harvest that bound communities together. The Green Revolution's emphasis on individual farm optimization and chemical inputs disrupted these systems. The crop that had created collective civilization was being remade in the image of individual capitalism. Rice today. Global rice production today exceeds 500 million metric tons annually. Asia produces and consumes approximately 90% of it. China and India together account for more than half of global production.
Rice is also one of the most water-intensive crops on Earth. Producing 1 kilogram of rice requires approximately 2,500 liters of water, more than wheat, more than corn, more than almost any other staple crop. In a world where fresh water is becoming increasingly scarce, the water demands of rice cultivation represent one of the most significant resource challenges in global agriculture. There is also the methane problem. Flooded rice paddies are one of the largest sources of agricultural methane emissions. The anaerobic decomposition of organic matter in waterlogged soil produces methane at a rate that makes rice cultivation a significant contributor to climate change. Estimates suggest that rice paddies account for approximately 10% of global agricultural greenhouse gas emissions. The crop that feeds half the world is also warming it. The Japanese government has subsidized rice farming at enormous expense for decades, partly for food security reasons, and partly because rice cultivation is understood as the preservation of a cultural and social practice that defines Japanese identity. Rice paddies are considered part of the Japanese national landscape. They appear in art, in poetry, in the visual grammar of what Japan looks like. When young Japanese people leave rural communities for cities, and rice paddies go untended, it is experienced as a cultural loss as much as an agricultural one. In California's Sacramento Valley, the largest rice-growing region in the United States, an unexpected ecological benefit of rice cultivation has been documented. The flooded paddies, which cover approximately 500,000 acres, provide critical habitat for migratory birds on the Pacific Flyway. Millions of ducks, geese, shorebirds, and wading birds depend on the Sacramento Valley rice paddies as stopover habitat during their annual migrations. The engineered wetland that rice cultivation created has become inadvertently one of the most important wildlife refuges in North America. Rice farmers and conservation organizations now cooperate to manage field flooding in ways that maximize both yield and bird habitat, an unexpected partnership between industrial agriculture and ecological conservation. This is what rice keeps doing, creating connections, creating cooperation, creating systems of mutual benefit that no individual planned and no individual could have built alone. The grain that shaped collective civilization keeps producing collective outcomes, even in the individualist context of American industrial agriculture. Finale. A world without rice. No Yangtze River Valley civilization developing around paddy agriculture 9,000 years ago. No Chinese Han dynasty sustained by rice agriculture. No Angkor Wat, the greatest religious monument ever built, whose civilization rose and fell with its hydraulic rice system. No samurai culture in Japan, where a warrior's salary was paid in rice and a lord's power was measured in koku. No Banaue rice terraces in the Philippines, among the great engineering achievements of human history, built over 2,000 years without machinery. No colonial famines engineered through the extraction of rice from populations that needed it to survive. No green revolution that doubled and tripled yields, but also discarded 9,000 years of genetic diversity in a generation. A different shape to the history of hunger and abundance in Asia, and perhaps a different cognitive profile for half the world. If the rice theory is correct, if rice farming actually shaped how people in rice-growing regions think, then a world without rice is a world in which the cultures of Asia developed differently. Not better or worse, differently, with different balances between individual and collective, between competition and cooperation, between the part and the whole. One grain from the wetlands of the Yangtze River Valley. But here is what the history of rice actually tells us. Every food in this series has shaped the people who grew it and ate it. Sugar shaped the Atlantic world through slavery. Corn shaped America through industrialization. Honey sustained civilization through partnership. Rice shaped Asia through cooperation. The grain is not just the food. The grain is the civilization. And the most important thing that rice tells us, the thing that the rice theory makes unavoidable, is that we did not create our cultures independently of what we grew. Our cultures grew out of our crops. The way we think, the way we organize ourselves, the way we understand our relationship to other people, all of it was shaped in ways we are only beginning to understand by the plants we chose to cultivate 10,000 years ago. You did not choose to be individualist or collectivist. Your ancestors chose a grain, and the grain chose the rest.